Double replacement reactions always follow the exact same pattern. Two compounds reacting to form two new compounds. AB plus CD yields AD plus CB. The two couples are simply switching partners. And this consistency keeps up. In every double replacement reaction, the two reactants will always be aqueous solutions. These reactions, as far as our class is concerned, will always start with two aqueous compounds. To be completely honest, the only complicated part of double replacement reactions is the formula writing. Everything else follows the exact same pattern every single time. Here are some examples of double replacement reactions. When aqueous iron 3 nitrate reacts with aqueous lithium fluoride, the reaction produces solid iron 3 fluoride, that's the precipitate, and an aqueous solution of lithium nitrate. It's that simple every single time. You just switch around the couples. But these compounds can have some pretty complex formulas, so stay focused on your naming and formula writing rules. Here's another example. Phosphoric acid, H3PO4, reacts with strontium hydroxide to form magnesium phosphate and hydrogen hydroxide, HOH. Now, that's a new substance, so let's look at that second product a little closer. HOH contains two hydrogen atoms and an oxygen atom. If we rearrange this formula, we get H2O. That's water. So this reaction actually produces water as one of the compounds on the product side. This is a special kind of double replacement reaction because it started with an acid, H3PO4, and a base, SrOH2, phosphoric acid and strontium hydroxide, an acid and a base. When acids and bases react together, they neutralize one another, so we call this a neutralization reaction. We're going to spend a lot of time later on in the semester focusing on this type of reaction, but for now, just know the water counts as a new compound if it is formed as a product in a double replacement reaction. Here's an example for us to work through together. Aqueous lithium hydroxide reacts with aqueous barium chloride. So what information have we been given here? Well, lithium hydroxide is one of our reactants. That's a compound. And barium chloride is our second reactant. That's another compound. Whenever two compounds react together, we call that a double replacement reaction. So all we need to do here is just switch around the couples. Lithium hydroxide reacts with barium chloride to form, switch them around, lithium chloride and barium hydroxide. This process is pretty simple, but make sure you're paying close attention to those formulas. Every time you write a new formula, you need to recheck your charges and make sure your work is correct. Try this next one on your own, and yes, the formulas are going to get a little complicated. Two solutions of tin 2-sulfate and ammonium phosphate react together when they are both poured into a single beaker. Okay, pause the video, try to write out the correct reaction equation all on your own, and then press play and check your answer. When we try to write out the correct reaction equation for this scenario, we need to immediately notice the words two solutions. All solutions are aqueous, so anytime we see the word solution, we're being told that the substance's state of matter is aqueous. We also know that all double replacement reactions, at least in our class, will always start with two aqueous solutions. So that is a giveaway that we are working with a double replacement reaction here. We just need to write out our formulas and switch the couples around. All right, well, what substances are we working with? We've got tin 2-sulfate, that's SnSO4, and we've got ammonium phosphate. That's NH4,3PO4. Whew, that one is a doozy. Be careful anytime you have ammonium because that means you're probably going to have two polyatomic ions stuck together. Be very careful that you're using parentheses and charges all correctly. Go back and look at your naming and formula writing rules if you need help with that. These are our two reactants, and together they're going to produce SN3PO4 that's 10,2-phosphate, and NH4,2SO4, that's ammonium sulfate. With all these polyatomic ions floating around, these formulas get a little intense. This is why double replacement reactions are sometimes difficult for students. It has nothing to do with the reactions themselves, it's all about the formula writing. Just make sure you end up with logical combinations, a metal and a nonmetal, rather than two metals or two nonmetals. That's not going to happen as far as our double replacement reactions are concerned. Double replacement reactions in our class always take two ionic compounds and turn them into two different ionic compounds. So no metal on metal compounds and no non-metal on non-metal compounds. Make sure you're moving your couples around correctly. That causes some problems for students sometimes. Double replacement reactions are pretty simple, minus the whole formula writing thing. Use the practice examples I've got for you here and check your answers as you practice. If you need help with formula writing, go ask a question or go back into your naming and formula writing notes.